Hi guys, this is video overview 2 of the FixtureduinoMini open source code. Now in the previous overview, in the first video, we went over the test routines that you have to modify for your needs. Now let's go over the subroutines. Well, first let's look at these test routines. Notice how they are all kind of short and sweet. Uh, no test is really too long. And that's because most of the work is done in the subroutines. And I like to keep it this way because if you're doing a real test, you might have more than 10 tests. You could have as much as 50 tests or more. And you don't want to have to scroll all the way down to find them. And you keep your tests short and keep your subroutines long, or as long as you need them anyway. Now, here's all the subroutines that those tests call. The first subroutine here is the most important one. This is where the testing is done. It's called measure. And what it does is, here's the usage. You call out measure. The item is what you're measuring, which you will define up in your variables here. So an example of some of the items is the voltage divider is on analog pin 1. The ohm test is also on analog pin 1 on the resistor divider. The capacitor divider is on analog pin 2. And on analog pin 3, we just left open and floating, and we're measuring anything between 0 and 5 volts as pass. Of course, that's all it could possibly get. And then so that's the analog input for the measure test. And then just while you're here, I just want to show you the relay is controlled with data port 6, and the capacitor is controlled with data I/O, not port. It's just an I/O pin. Pin 7. So I/O pin 6 and I/O pin 7 is what controls the two relays. Okay, so let's get back to the subroutine. So that's what item is. You put in the item. The high voltage is not 5 volts, but it will be a number from 0 to 1024. 5 volts would be 1024. 0 would be 0 volts. 1 volt would be 1024.8. But we use 1025, we just round it off. And the low voltage is the same thing, 1024 to 0, but a little lower than this one. So you're measuring between these two voltages. And then here, the percentage of hits is going to be a number from 0 to 100. So if you put 80, normally I use about 80, so if it passes between this 80% of the time, it passes the test. And we test 100 times. If it hits 80 times, it passes. So you don't really have to test a full 100 times. As long as it passes 80 times, it'll pass. If it passes 80 out of 84, then it passes. And it only had to do 84 tests. So basically how it does that is it cycles here. You have this loop right here where it cycles and takes the measurements and increments it each time. And if the hit is higher than the percent, it breaks out. And then it prints this. It'll print the measurement, some number between 0 and 1024, the number of passes, and the number of times it cycled, it checked. So that's what the measure does. So that's the main program that all these subroutines are calling as a subroutine in the subroutine file. Now this one here is a voltage the routine that's called when measuring the voltage in the resistive divider. What we have here is the text that we put out into the buffer. So let me explain this print buffer a little bit here. The print buffer is kind of an amazing feature that we offer. It allows you to put text into a buffer and then print it out serial. Now the thing about the LCD display is you can print text and numbers anywhere you want just by defining it on the display. But you can't do that with serial. So to get something like this is what you would get with your tape printer when your serial output, when you print what comes out of the serial port. or you measure it with the Android system or however you want to do it, you'd get something like this. And what we are able to do is put this voltage in with this text that says what it is. Voltage equals 1.00 volts, or voltage equals 2.5 volts DC. You couldn't normally do that without a text buffer. Without a text buffer, you would have to say on one line voltage equals, then output the voltage 2.5, and then the next test you'd have to put voltage minimum and then output what the minimum voltage was supposed to be. But here you can combine it all together. Now the way that's done is a text buffer is set up here. This is really the text buffer. It's also a good place to put the part number and name. So put the part number and name of the circuit board you're testing. Put whatever kind of test you're doing here. This will print on the first line of the LCD, and this will print on the second line of the LCD when you first start up the fixture, basically. But its main function is to reserve space for the character. And then this is what's going to go out the serial. It doesn't really go out the serial here, but it's the space reserved for whatever you do put out serial back here. So that's what this is all about right at the beginning in the FixtureduinoMini file. Okay, so back to subroutines. So this is printed into the buffer, and then the values are inserted into the buffer on 0. 1 is the decimal place leaved in, and 2. Here's 0. This is an integer, low voltage divided by millivolts. It's going to take the first integer. Now this uses the modulus function after the decimal point. This is what the modulus function was originally designed to be used for, is to take integers and make them look like floating points. Back in the old days before there was good floating point math available. So they used modulus this way. And the reason we're doing it is mostly just so that we can control where this decimal point is. So it's not floating all around in different places and making the LCD flash all over. For example, to show you what I mean here, say you're measuring between 10.1 and say 9.9 volts. Okay, now we can put a 0 here. This is a really nice way to do it because as the measurements change, the decimal point stays right here the whole time. If you use floating point, what's going to happen is you're going to get results flashing between here and here. So the decimal point is going to be jumping around the display, and your display is going to be flashing, and it's just going to look messy. So with using the modulus techniques, you can have it display something similar to this. Now you might think, well, this modulus thing is so complicated. Look at this, and then look at over here how big and messy it gets. Well, basically it's not so bad. The thing that changes is the numerator. The denominator is always the same, and the part of the numerator that changes is just the signal, the sig variable. So basically, let me show how to derive this from these two, and then you can continue on for a really long time here. I'll move this over and let you see this. So we'll take this, just using cut and paste, we're going to make this formula. So we'll paste this here. Okay, now the second part of this, you just take this. Now I'm going to copy this, and it's always going to be in my copy buffer, Control V or Control C. Now I'm going to replace sig with that. Okay, now I've got this, of course. Now to get this, I just replaced sig again with the same thing, Control V. To get the next decimal place over, the third place instead of the second place, I just go like this. Now look at how complicated this got, but it was very simple to acquire. Okay, so that's how simple it is to use modulus. You basically just take this and start replacing sig. Control V. Now just notice that this is the same as this, and again I'm just going through the same thing again. The next decimal place over would be this. Okay, so that's how simple Modulus is to use. Now let me move this back where it should be, in the center of the window here. Okay, ready to move on. Now the rest of these are just more of the same for measuring the capacitive divider, for measuring the ohms on the resistor in the instead of voltage. You'll notice the formula for getting ohms is a little bit different than the voltages, but it's basically the same kind of thing, just a little bit of math applied. Then this last one is the serial open. Now in all these I want you to notice how this is called out. So print serial ohm, print serial open. In the open, this is the analog 3 pin that is just left open. It's a good thing to show you this. We're calling integer low volt, integer high volt, percentage of hits. So we're calling it, let's go back to the test and show you how I call it. It's going to be called with 0 and 5. It's test 5 right here. Print serial open is the function, 0, 5, and 80% of the time. So it's between 0 volts and 5 volts, and it hits 80% of the time. So we get in 0, 5. This is the default, would be 5 anyway. I wouldn't have even had to call that out, and this is also a default. So all I would have really had to call out was print serial open in parentheses 0, because the rest would just be filled in automatically by the defaults. But I filled in the defaults anyway just to give you a better idea of what it does. So then what we're doing here is we're using this math. 1 volt equals 205. It actually equals 204.8, but 205 is close enough. And this math then converts the voltages we're passing. To make it easy on ourselves, we pass voltages. It converts that to the analog to digital output, which is 0 to 1024. 1024 to 0, anything between that. So it converts that to the proper values based on these, and then sends it out to the print measure, and then it converts it, which takes those digital values and gives you a pass-fail, and then it measures the signal back and converts it to print it out here on the last line of the LCD display. That's how all these subroutines work. Okay, this concludes the video on the test subroutines. In the next video, I'll go over the debug tests. Hope to see you in the next video.